Welcome everyone. Great to see you back here today and ready to learn more about smart contracts and Chainlink. Yesterday, we gave you a brief introduction to blockchain, Chainlink, and smart contracts, and some of the things that you can do when you create smart contracts in Remix, and kind of playing around with arrays and things like that, and doing some smart contracts that make use of Chainlink as well. Now, these were just the first steps, and we kept things simple, playing around in Remix, keeping things nice and easy, nice and simple, and hopefully you're able to successfully create, deploy, and interact with some smart contracts. Now, today we're going to step out of the sandpit and jump into the boxing ring where all the big kids play. So we're going to learn about another development environment called Hardhat. I'm going to get some solid hands-on experience working with Hardhat, and we're going to do all kinds of fun things with it. So it's going to be very hands-on today. There's going to be very little slides and kind of me talking through slides, and it's going to be a lot of hands-on stuff. So it's going to be awesome. So hold on to your hats and get ready to take your next step in your journey as a smart contract developer. So once again, my name is Harry Papakarisiou. I'm a developer advocate for Chainlink Labs. I'm joined today in the Zoom session with I have Zach as well from the DevRel team, and we have Colin from the community who's going to be helping us out. And in the community, in the YouTube, we've got Josh jumping in and out to do some moderation, as well as some other ambassadors and community members, Scott, Kevin, and Juan, I think, that's going to be helping out as well. So today is day 2 of the weekend developer bootcamp track. So it's a very full-on day today, lots of stuff to get through. So yesterday we focused on learning the concepts, creating your first smart contracts, doing things in Remix, getting familiar with all of the kind of nuances involved in smart contract development. Today, the aim is to focus on Hardhat, to get you guys familiar with Hardhat, get you guys familiar with how it's used as a development environment, and all of the kinds of things that you do with it when you do smart contract development. So it's probably about 90% exercises and demos and 10% presenting in slides today. So that's good. Hopefully my voice isn't as shot as yesterday at the end. So we're going to talk about development environments and Hardhat. Then we're going to go through what we call our Hardhat starter kit. And then we're going to go through things such as working on the local Hardhat network. We'll talk about smart contract security and testing, and then we'll finish up with where you can go to learn more. So once again, very similar to yesterday, today's going to be about 4 hours broken up into sections, and it will be a bit of presenting, some of me doing a demo, and then it will be exercises where you guys will kind of go through the exercises. And if you have any questions, once again, you can ask at the end of each section, either in the chat or turn your audio on and ask in person. We encourage lots of questions. And if you need help during the exercises and you're in the Zoom session, once again, put your hand up in Zoom. An instructor will send you a URL that you need to click on to go into a one-on-one with them, and then they can help you solve your issue. So if you do have your hand up, keep an eye out for that URL, and you can get help that way. And if you're on YouTube, post your questions in the chat. We'll be monitoring. We'll try to help you out when we can. Now, very importantly, at the end of this session, we're going to send out a feedback form once again. If you want a certificate of attendance sent out after the bootcamp, make sure you fill this out with your email address so that we can send that out to you. Okay, so let's get going. So let's talk about development environments first. So a lot of you probably know a development environment is just a kind of set of tools or software to kind of to code, basically. It's used to build applications and to kind of maximize productivity and efficiency. So yesterday we were using Remix, the web version, and it was it's purely in the browser, so you don't actually have to install anything. And it has modules for testing, debugging, and deploying smart contracts. As you guys saw yesterday, it's got a local JavaScript VM that we can use to simulate running smart contracts on Ethereum. And it was very quick and easy to use, and it had a graphical user interface where you can click on buttons and things like that. And it's really great for beginners. However, there are some limitations of Remix. You can only deal with smart contracts generally with Remix. You can't easily integrate other parts of a project. So let's say you have a front end, you're building a hackathon project or something. You can't easily integrate other parts of a project in Remix, and it's got limited support for testing. And it kind of saves everything in your local browser cache, but you can't save files locally without using plugins and things like that. So if you need to create a real project that contains smart contracts, tests, front end, and all of these other types of things, you need a more feature-rich development environment. So one of the most popular development environments going around for smart contracts development at the moment is Hardhat. So Hardhat is actually used by many smart contracts developers right now, whether it's for creating just projects, hackathon submissions, to full-blown DeFi applications running on mainnet. So they've got a really good website as well, which I'll just quickly show you. So, whoops, too big. Yeah, so hardhat.org is the place to go if you want to find out more. So the Hardhat is oops, let me go back. So Hardhat's a JavaScript-based development environment. It does support TypeScript as well. And it's basically an environment that lets you create, compile, deploy, and interact with your smart contracts. And it's got a cool local Hardhat network, which we'll get into in a minute for doing local development. It's got a whole bunch of plugins that you can use. It's got all these debugging features, and it's got these cool things called tasks and plugins as well. So a task is kind of like a script, but it's more modular and flexible, and it can be called within other tasks or scripts, and it's kind of like a more flexible version of a script, and generally use it to automate common tasks. And you'll see what I mean by this later, because we're going to work with tasks. And you can actually package these tasks into plugins that can then be imported into other projects as well. So yeah, and just to finalize, Hardhat's got a whole bunch of plugins that you can use right off the bat, including support for Web3 and Ethers.js. So if you don't know what those are JavaScript libraries for interacting with Ethereum from your JavaScript or Node.js based applications. So we're actually at the first demo now. So I'll quickly go through this first, and you guys can just see what I'm doing, get a bit of context, and then we'll give you guys plenty of time to follow along after that. So if you haven't installed VS Code and all of the other stuff in the setup instructions, definitely recommend you do that now. So this is my Visual Studio Code here. Hopefully that's a decent size for you guys to see. And in the instructions, you're going to manually create a folder and initialize a new Hardhat project, but I've kind of already done that here. So in terms of what VS Code is, it's a really good editor, as well as it has a whole bunch of features that are really good for smart contract development. It's got an integrated terminal that you can use here, which is really cool, because then you can code stuff here and then run commands right underneath. So very helpful. And on the left here, this is the Explorer bar, if you will, where whatever folder you're currently in, you can then, traverse through other folders and open files, edit files, etc. So that's about it for VS Code. Once you've initialized your first Hardhat project, you're going to see a bunch of stuff here. And what I'm just going to run through is just the bare bones of a Hardhat project. So the first thing is the hardhat.config.js file. So this is a special config file that every Hardhat project uses that kind of defines all of the high-level config stuff. So in your first Hardhat project here, you're going to specify the default network that you're going to be deploying smart contracts to. So in this case, it's Coven. And you're going to be specifying which version of the Solidity compiler you want to use. So in this case, it's 0.073. So very similar to in Remix yesterday when we could specify a compiler version as well, and where we could specify a network as well. The difference here is in this config file, we're also importing a few packages. So in this case, we're importing Hardhat ethers, which is a Hardhat library for interacting with the Ethereum network. So we're going to be using that one. And we're importing a .env config, which is, it allows us to put configuration variables in a .env file. So if you don't know what that means, here's an example of one. So if you've got certain, and these are just dummy values here, if you have certain information that you need to, or variables you need to use in your project that are sensitive, like private keys and things like that, but you don't want them in your source code, you can put them in a separate file, which we call a .env file. And then these can then be referenced in your Hardhat project. So in our hardhat.config file, here for the Kovan network, whenever we do a deployment to the Kovan network, we're saying the account we want to use, or the wallet we want to use, is from process.env.private key. And what this does is it will then go to your env file and it will find this private key environment variable, and it will grab that and then inject that in and use that. So it means we don't have to actually put any private keys or sensitive information in our code here. So that's the purpose of the .env file, is to kind of store the private key from your MetaMask wallet that you hold ETH and link in, because in this case, we don't use MetaMask in Hardhat. Hardhat does all the deploying for us. We give it the private key and it just automatically signs transactions on our behalf and does them. So we don't have to approve them in MetaMask or anything like that. In addition to this, we're storing the Kovan RPC URL, which you guys should have set up in the setup instructions for Hardhat. So you'll need to grab that kind of that key that you were given over here. If you haven't got it yet, you can go to Infura right now and sign in, and you should be able to find it. And you plug that in there, and that's actually used to connect to the Ethereum network. So because we're not using MetaMask, we need a connection to the Kovan network where we're not running a Kovan node. So we're using Infura to kind of gain access to the Ethereum network there. We don't actually need this one for this exercise, so just ignore that. So that is the main config part of our Hardhat project. And in terms of the other stuff we have a whole bunch of metadata here, which don't worry about that for now. There's always a contracts folder, and the contracts folder is where you store your smart contracts. So in this case, in this exercise, we're actually recreating the My First Contract smart contract that we played around with yesterday, and we're going to be doing some stuff with it in Hardhat today. So it should be familiar to you guys from yesterday's exercises. And in addition to this, there's a scripts folder, which is where we put scripts, basically. So in this case, there's one script as part of the main exercise. It's called deploy.js. And if you have a look at the exercise and you see the contents of the script and the syntax, all it's doing is it's using ethers.js to kind of, it's using ethers.js to basically grab your, your wallet address, your account, and it's saying, using this account, I want to deploy my first smart contract to the specified network. And that's all it's doing there. And once it's deployed, we can literally call functions in that smart contract by calling deployed contract dot, and in this case, there is a set number and a get number function. And all we're doing is we're calling the set number, passing in a number, and then we're calling the get number function to kind of see the result of that. So very simple script that simply deploys a smart contract and then calls a couple functions. So I think once that's done, we can compile the contract. So this is the command to compile. Because I've already compiled it, I get an error, but I'll try it again. By the way, in VS Code, the up key is on your keyboard is your friend. It goes through your history. So you'll find yourself using it a lot so that you don't have to keep typing in commands. So npx hardhat compile will go through and it will compile any smart contract in our contracts folder. And once that's done, we get a compilation finished successfully, and we get a whole bunch of metadata generated in these artifacts and cache folders. If you go into artifacts, contracts, and into the sol file here, and the JSON file, you can actually see the ABI, which we discussed yesterday, the application binary interface. You can see that generated here along with the bytecode for the smart contract. So that's kind of just some metadata. So once we've done the compile, we can then run npx hardhat deploy. No, sorry, that's not the right one. Once we've done the compile, we need to manually execute the script. And to do that, we run the command npx run, npx hardhat run, and then we pass in the script name. So we're saying we want to run this script. So as you can see, it's deploying the smart contract with our the private key that we specified. So we don't have to do anything in MetaMask. It's signing and doing transactions for us because we gave it the private key. And we wait. So our smart contract has been deployed, and we get given an address that it was deployed to, which I'm going to copy. Cool. And as you can see, it called the two functions, and it set the number to 7, and then it retrieved it. So if I copy this address and I go to coven.etherscan, I should be able to search for my created contract, and you can see it was created, and then we called the set number function on it too. So in this Hardhat project, we created a new smart contract. We created a script to deploy and then kind of interact with it. And then we compiled the contract, and then we ran the script, which then deployed the contract, and we interacted with the contract. So I think that is it for the first exercise. Yep. So I'll pass it along to you guys now to have a bit of a play. Just remember, in your make sure you've got your .env set up correctly with your correct private key from MetaMask and your Coven RPC key over here. If you have issues when you run npx hardhat compile or deploy, I think there is a troubleshooting section at the end of the exercises. Check that out to see if any of the issues apply to you. And if not, reach out for help either in the chat, or if you're in Zoom, put your hand up and we'll try to help you out. So I think for this exercise, we'll give you guys a good 45 minutes to have a bit of a play, and then we'll continue a bit after that. Nice work there. I think we need to continue now. If you're still going, don't fret too much, because we're going to be going into another exercise very soon, and you can continue where you left off from. But yeah, if you can just bear with me for a few minutes now. Let me just get my bearings here. Cool. So congratulations for those of you who completed the exercise and were able to successfully deploy and interact with a smart contract with a Hardhat project. Great work. You've now taken the next step in your smart contract developer journey. And I just want to show you guys a couple of things to let you know that for those of you who may think, this is all over your head, and it's all a lot to take in, and that you guys are doing awesome. And I just want to show you a couple public GitHub repositories here. So here's Uniswap v3. As you can see, this is a Hardhat project, just like the project that you guys were kind of working with. Here's Synthetics, a repository for their contracts. Once again, they use Hardhat as well. And one more, This is Aave v2 contracts. And once again, they also use Hardhat. So you guys are using the same development environments that some of these big DeFi players are using, and you're creating contracts, you're deploying them, you're running scripts using the same tools and the same development environment that these guys use. So congratulations. For now, let's go on and talk about the Hardhat starter kit. So the Hardhat starter kit is a repository that's pinned to the top of the Chainlink GitHub. As you can see, we've got 3 different starter kits, and the Hardhat one is, this one here with a cool little yellow hat. So the Hardhat starter kit is a pre-packaged Hardhat repository that we've created, and it contains a whole bunch of things so that you can take this and use it as kind of like a boilerplate project whenever you want to build something in Hardhat where you need smart contracts, or you want to build smart contracts that interact with Chainlink. So it contains template smart contracts to interact with Chainlink. It contains all these deployment scripts. It contains tasks, configuration, and tests as well. So it's all pre-packaged in this one repository. And it allows you to quickly build, deploy, and test smart contracts that need Chainlink. And it could be integrated with any other parts of a project. And it's got a whole bunch of custom tasks to kind of increase productivity whenever you need to create a smart contract to, get a random number or use a price feed or things like that. So I'm just going to show you now what I mean, and then you guys can then move on to the next exercise. So I'm just going to switch up to hopefully that's the right one. Cool. So once again, this is a Hardhat project. In this case, you're pulling it from GitHub, and it's already been created, and you're just kind of changing a few things on it. So once again, we have a contracts folder here, and in the contracts folder, we have 3 main smart contracts: API consumer. So this smart contract should be familiar to you guys from yesterday. It is the template smart contract for reaching out to an API, and you guys did some deploying and interacting with it yesterday. There is the price consumer contract, which once again from yesterday, we used to deploy and then interact with a price feed. And then the random number consumer contract, once again from yesterday, we used to get a random number using Chainlink. So the 3 smart contracts that you played around with yesterday are in here as well. There is a bunch of mock scripts, contracts in here that we're going to be using for local deployments in another exercise. So just ignore those for now. In addition to this, what else do we have in here? We have a deploy folder here, and we have a deploy script for each of the contracts here. Ignore the mocks one for now. So these are scripts to deploy each of the smart contracts, and you can kind of go through and see the logic yourself. But essentially, each of them just, depending on which contract it is, it will kind of get your wallet address or your kind of account, and then it will deploy the given contract. And sometimes there's some logic where it says, if you're running on a local network, do something else, but just ignore that for now. But for the purposes of this exercise, it just deploys a smart contract, passing in certain parameters, which we'll get to in a minute. So other than that, we have a hardhat.config file as well, just like we did in the last project. In this case, we're importing a whole bunch of tasks, which I'll go through in a minute. We're using a .env file once again to store our private key and our Kovan RPC URL. And just like in the other exercise, we have a default network. In this case, we want it to be Kovan. And we're using the private key from the .env and the Kovan RPC URL as well. So very similar. In addition to that config file, we've created this other one called helper hardhat config. And this has a bunch of environment specific configs that we use throughout the smart contracts, such as the link token address for Kovan, the ETH/USD price feed for Kovan, the VRF kind of key hash and things like that. All of those things that we usually obtained in the Chainlink docs.chain. So all of those kind of things that we obtained in the docs, such as the for example, the VRF coordinator, the link token, the key hash, those kinds of things we're storing in a config here, as opposed to us manually going and putting them in. And apart from that, there are some tests, but just ignore those for now. Let's have a look at the tasks now. So there's a bunch of generic tasks defined in this Hardhat project, such as accounts. It will kind of get you the account that you have, the private key. You can get the balance of your account. You can get the current block number of the network that you're connected to. There's a task to fund a contract with Link, where you literally call the task and you pass in a contract address, and it will automatically send, I think, 1 or 0.1 link to it for you. So you don't have to kind of do that kind of thing in MetaMask that we were doing yesterday, where we had to manually fund a contract. You can just call a task to do it now. And we also have some contract-specific tasks here. So, for example, the price consumer folder has a read price feed task. This takes the contract address of the contract that you deployed, and it will call the get latest price function, which, as you guys will probably remember from yesterday, is this one here. So because there's no graphical user interface in Hardhat, everything's done on the command line, on the CLI. So to interact with contracts once you deploy them, you either need to have scripts or you need to have tasks in the case of Hardhat here. So we've got a bunch of tasks that you can then use to interact with contracts once you've deployed them. So that's the one for price feed, and there's ones for reading a random number, for requesting a random number, and then reading the result as well. So these tasks are specific to those 3 smart contracts that we've created here. But you can just imagine if you wanted to create your own smart contract that does your own thing, you can create the contract, put it in the contracts folder, then you could take one of these tasks and sees how it gets a deployed contract, how it connects to the wallet, and then how it calls a function. And you could just use that as a template to kind of create your own task or your own script as well. So they're quite handy. And in terms of the Hardhat repository, I think that's it. So I'm just going to do a quick demo now, and then you guys can have a bit of a play. So I'm setting my default network to Kovan, and I'm going to go npx hardhat compile to compile all of the smart contracts. That's all done. Now I'm going to go npx hardhat deploy. And what this does is it will actually go through the deploy folder, and it will run all of the deployment scripts in order. And as it runs them, you'll see that we actually get some output in the console as well. So these deployment scripts have been set up to give output that you can then copy and paste to actually run tasks to interact with them. So I might just make this a touch smaller. Hopefully, let me know if that's too small for you guys. But as you can see, it's deployed the price consumer contract to this address, and it's saying, run the price feed contract with the following command. So it's saying, run the read price feed task for this contract here on the Kovan network. So we can literally copy that line and then paste it and then hit enter, and it will execute that read price feed task, which is this one here. So as you can see, the task executes and it says reading data from the price feed contract, and it tells you what the current price is. So once again, we can do it for one of the other tasks as well. So we can run the request random number task on the VRF contract, and it will run that task, which will request a random number using the specified values. One thing you'll notice is I haven't funded the VRF or the API contracts with Link like we had to yesterday. That's because there is a setup contracts script here, which actually does that for us. It goes through and it says, okay, for the API consumer contract and the VRF consumer contract, let's fund it with some Link. So I didn't have to do it myself. So I ran the read random number task here and it gave me, request random number task here and it gave me some output. And now I can literally just copy the output that says, all right, to read the random number, run the read random number task. And I'm just pasting it there. And hopefully we've waited long enough to get a response. So there you go, there's our random number. So what I've done here is essentially using the Hardhat starter kit, I've just kind of compiled and deployed the contracts to the Coven network, and then we're interacting with them using the tasks. So it just gets you kind of familiar with deploying and interacting with contracts in Hardhat. And in this case, the contracts should be familiar to you, and kind of the things that the contracts do should be familiar from yesterday. So that's it, I think. I'll pass it over to you guys now, and you can play around for a bit. Download and set up the starter kit and hopefully deploy and interact with the contracts. So hopefully everyone was able to download and deploy some smart contracts in the Chainlink Hardhat starter kit and then interact with them with the tasks. I know a few people have had some niggling issues with NPM and things like that. Don't fret too much. We've got another couple exercises where you can hopefully catch up, and we'll try to help you out where we can. But for now, we're going to move on. So now that you've kind of deployed smart contracts and interacted with them with tasks on the Coven network, let's talk about doing similar exercises with a local Hardhat network. So just to reiterate, the Hardhat network is it's kind of like running a local Ethereum network on your computer, and whoops, pardon me. It allows you to kind of deploy, test, and run your smart contracts. And it's really cool because it's all on your computer. You don't need to worry about funding with ETH or faucets or anything like that. And it's all really quick. Everything gets mined straight away. And it's great for kind of just creating your smart contracts. So you can use plugins with it, and you can kind of think of it as just like another network, just one that's really fast. However, take note, you can't connect to things like the Chainlink network or anything like that when it's running on your local computer, generally, because in the case, for example, with Chainlink, let's say you want to make an API call to a Chainlink node then can't then write a transaction back to your local blockchain running on your computer. Another cool feature of the Hardhat network is you can fork the mainnet. So what this means is it takes a copy of the current Ethereum mainnet or a snapshot, basically, and it says, I want to use this as my starting point for my local Hardhat network. So initially, when you start a local Hardhat network, it's a blank slate. So the blockchain has no blocks. You get a bunch of accounts with a whole bunch of ETH, and then you can use it from that point. But what if sometimes you're building a smart contract or smart contracts where they interact with other contracts that already exist, such as, let's say you want to build a DeFi smart contract that wants to interact with like an Aave lending pool, right? If you want to create your contract and then test the interaction with the Aave lending pool, etc., you then need to get all the Aave smart contracts and deploy them and play around with them. Whereas if you just fork the mainnet, then those deployed Aave lending pool contracts on mainnet are there ready for you to go and interact with them, right? So they're not the real ones on mainnet, but they're kind of, you can think of it as just kind of like a copy on your local Hardhat network that you can use. Another thing with local deployments we use is what are called mocks. So as I explained earlier, because in this case, because we can't have a connection to a Chainlink node when you run a local Hardhat node or network, we create what are called mocks. So mocks are just smart contracts that pretend to be something else, but really they're just kind of like a smart contract or a script or something. So in this case, we can have a mock a mock Oracle contract to so that our API consumer thinks it's sending a request to a Chainlink node, when in reality it's just sending it to our kind of mock contract, and our mock contract is then getting the request and then sending a response back. So we're kind of just imitating some of these other things, and this is useful for testing on local networks where the state isn't the same as a public network. So I'm just going to give you guys a bit of a demo now of this. So the purpose of this exercise is just purely to get you familiar with the Hardhat local network and kind of doing some of the things in it. So the first thing that we're going to do is we're going to change the default network to Hardhat, very important. And another thing, oops. The next thing that we're going to do is in your .env file, make sure that you've set your Alchemy, your mainnet RPC URL from Alchemy here as well, because we're going to use that soon. And what we want to do is, there's a little plus button here in your terminal in VS Code, and this allows you to open a second terminal, as you can see. And the reason I'm going to run a second terminal, and you can see you can switch between the two here like this, is because we're going to now run npx hardhat node here, which is going to start our local Hardhat network over here. So we get a whole bunch of output, and you can see it started and it's running. So we run it in one terminal, and then we go back to the other one to kind of, you know, do stuff to it. So I'm going to now run the deploy, npx hardhat deploy, and hopefully we get a bunch of output. So you see how quick that was compared to doing it on Kovan. Everything's running on our local Hardhat network, which is a blank slate. So now that everything's deployed, I can actually go and call the tasks as well. So I'm going to grab the output for the price feed task, and I'm going to run it. And as you can see, we get an output. So this price, we didn't actually get it from a price feed because we're running a local Hardhat network. Once again, we actually use the mocks here, the mock contracts. So in this case, when the price consumer was deployed, it actually used the mock aggregator contract here, which is, where is it? Yeah, over here. And we actually deploy the, where is it? Sorry, just bear with me. Deploy mocks, there it is. So here we've got a static initial price that's set, and if we're working on a local instance, our Hardhat network, we're actually deploying the a mock version of the link token along with a mock version of the aggregator contract. So we're not really reaching out to a price feed, we're reaching out to a mock price feed. But it's all local, it's all done in our local Hardhat kind of network here. But let's say we do want to reach out to a real price feed. Let's say we're building a DeFi contract that uses the ETHUSD price feed, and we want to test things locally. This is how we can run a forked, we can do this with a forked version of the mainnet. So if I go back to my running Hardhat node, I'm going to actually hit Control-C to kill that node. And then back in my Hardhat config here, I'm going to uncomment this forking section here by removing the 2 forward slashes on those 3 lines and then saving that. So that's going to grab my Alchemy mainnet thing from my env file here. It's going to grab this and it's going to use that to fork the mainnet. In addition to this, there's a couple other things that we need to do. In our Hardhat, helper Hardhat config file, sorry, for the local network here, we're going to actually put in a new config called ETHUSD price feed. And this address is actually going to be the address from our, well, that's a bit big. It's actually the ETHUSD price feed contract from the Ethereum mainnet, because we're going to be using the ETHUSD mainnet price feed in our forked network, basically. So that's specified there. And the last thing that we need to do actually is, because we're using a forked network and we want to connect to the mainnet ETHUSD price feed address, in our deploy price consumer script here, we're actually going to comment out this if statement. So this if statement currently says, if you're doing a local deployment, grab the mock aggregator. Otherwise, get the ETHUSD price feed address from the Hardhat helper.config file. We actually want to always get it from the Hardhat helper Hardhat config file, so that even for a local deployment, we want it to go to this file and look up this value here for the ETHUSD price feed address. So I'm going to save that. And now I'm going to restart my node. And because we uncommented this forking section here, it should start it as a forked version of the mainnet. So it'll be a little bit slower than doing a true local deployment that's not forked, but it still should be generally pretty quick. There we go. So the best way to tell that you are working on a forked version of the mainnet is, first of all, I'm going to deploy the contracts again to our forked version of the mainnet. So just wait a minute for that to occur. There we go. So everything's deployed to our forked version of the mainnet. And I'm actually going to run the block number task now in our starter kit to see if we're actually running on a forked version of the mainnet. Because if we're running a true local network, it should be on block 0 or 1 or something. But if you have a look here, the current block number is 128.96662. If I go to Etherscan, this is the mainnet Etherscan. You can see the block number 128.96668. So just a few blocks behind. So that's how I know I'm actually running on a forked version of the mainnet. If I run it again, it will probably be a little bit higher. There we go. So now that we know we're running on a forked version of the mainnet, I'm actually going to call my read price feed task again. And as we specified earlier, our read price feed, our price feed contract is actually going to look at the mainnet ETHUSD contract address. And as you can see, we actually get the price of ETH here. If I go to the ETHUSD mainnet price on the Chainlink website, we get 2125.88 and 2125.878. So that actually verifies that, yes, our price consumer contract is looking at the ETHUSD mainnet price feed on our locally running Hardhat node that is a forked version of the mainnet. And it will continually update as well. So anything that you deploy on a forked version of the mainnet obviously comes from you and it's all local, but then all of the stuff that's happening on mainnet also gets included as well. So the block numbers will continue to go up and you have access to anything that's on the mainnet, but kind of on your local Hardhat node, if that makes sense. So I think that is it for the demo. So yeah, just in conclusion, the whole purpose of this exercise is to just get you familiar with starting a local Hardhat node, deploying some stuff to it, interacting with the contracts, and then trying to fork the mainnet and then change the deployment of the price consumer in a way such that you can see how you can actually interact with mainnet deployed smart contracts on your local Hardhat node. So very exciting stuff. We'll give you guys probably about half an hour on this one to hopefully get it going and reach out if you have any questions. So yeah, this is very useful because you can do stuff all locally without needing Coven, ETH or Link or anything, but you still have anything that's on the mainnet that you want to interact with your smart contracts. It's all there for you to interact with it, but obviously not on the mainnet. All right, hopefully most of you guys were able to play around with a local Hardhat node, and hopefully you guys are also able to fork the mainnet and deploy some contracts and then kind of interact with them and see how you can kind of use the mainnet price feed address in your deployed smart contract. So that was kind of just to get you guys familiar with forking the mainnet and running a local Hardhat node and seeing the difference between deploying and interacting contracts on a local Hardhat node versus doing it on Coven. So now let's move on to smart contract security. So whenever you're dealing with smart contracts and blockchain in general, you kind of have to be a bit paranoid because there's nothing's hidden in the world of blockchain, and you have to assume that if you have a contract which has value in it or the potential to have value, then you have to assume that people are going to potentially target it if it's deployed on mainnet. So if you're a developer, you might know a couple of these things already. A bug is just an error or fault in the code that causes it to produce an incorrect response. And generally, there's two main sources of security problems in Ethereum, either a bug in the protocol itself or a bug or a vulnerability in the smart contract. So generally, most issues are in the second bucket here. Ethereum's become, quite mature over the years. However, there still are small issues that come up every now and again. So previously, we've discussed smart contract exploits due to, using insecure randomness or using centralized oracles and things like that. But now we're going to talk about pure on-chain smart contract security. So in terms of the life cycle, a smart contract can be thought of more as hardware rather than software. If there's an issue in software, usually the software manufacturer can just kind of release a patch or an update that gets sent out and everyone can install it, and then the issue's resolved. But with a smart contract, once it's on the blockchain, it's immutable, and unless it's specifically programmed to be upgradable, it can't be changed, right? So it's kind of like a car or just something that's a physical thing, where if an issue is found, generally it kind of needs to be taken back and you get a new one. So there are a bunch of well-known smart contract attacks that I've listed here, and when we send the slides out, you guys can have a look at this link. It's got some info on all of them. However, due to time restraints, I'm not going to go through them all here. However, if you're going to be attending SmartCon in the next week or so, I'm going to be talking about some of these things in the developer track. So if you're interested in that, check out my presentation. So how can we minimize the chance of bad things happening in our smart contracts? One of the best things is testing. So testing is one method of trying to increase the overall security of your smart contracts. So obviously testing in the context of smart contracts is trying to find any gaps, errors, or missing requirements. And once again, just reiterating that smart contracts are immutable. And when you combine immutable programs that hold and control movements of value and funds, it becomes clear that testing is extremely crucial. Some of these points would be familiar for developers. And once again, just want to reiterate that tests are really good for catching mistakes and errors. And the more of your code that you can test, the less the likelihood of there being an error in your code. So a vulnerability is by definition something that's kind of unplanned. So you can't really take into account when kind of doing your tests, whereas a bug is something that kind of you plan for and it didn't kind of go as expected. So generally we work with two types of tests with smart contract development: unit tests and integration tests. So unit tests are just simple bits of code that verify a single behavior or component within your code. And an integration test is more complex and generally tests interaction with other contracts or things external to the blockchain, such as a Chainlink node or something like that. And the general testing approach that's taken, once again, probably similar if you're a developer, is the arrange, act, assert testing pattern. So we arrange the initial conditions required for the test. Then we act by calling the function that needs to be tested. And then we assert the result of the action. And you'll see what this means in a minute if you're not 100% sure on it. So writing good unit tests comes down to a few things. So a unit test should be simple. Each unit test should be evaluating just one single thing. They should be repeatable. So each unit test should always produce the same result, no matter how many times you run it. They should be isolated. They should not depend or affect each other, right? So you should be able to run your tests in any order together or independently and always get the same outcome. They should be readable with plenty of comments so that someone else who comes along knows what's going on. Because once you finish writing a test and once it's kind of passed, generally it will kind of sit there for a long time until there's an issue that comes up and then someone else will come in and try and work out what's going on. And 5, tests should be fast because when you're building complex smart contracts and things like that, generally you're going to have a lot of them and you kind of want to be able to run them in a fast manner when you're constantly changing things. So integration tests, as I said earlier, test interactions between contracts and also on and off chain components such as oracles. And we have what are called JavaScript tests as well, which test the behavior of things external to the blockchain. For example, if you have a front end that you want to connect to your smart contracts, JavaScript tests are great for testing that the front end is actually able to successfully interact with your contracts. So there's a couple of tools for testing listed here. Mocha and Chai are very kind of mature, well-known JavaScript testing frameworks and assertion libraries, which you'll see in a minute. And Waffle is a really popular library for writing and testing smart contracts. You'll play around with these in the coming exercise. Solidity coverage is a really cool tool that you can use to actually see how much of your code is being tested in your tests. So it basically looks at your Solidity contracts, it looks at your tests that you've written, and then it will basically give you a report that says how much of your code has been covered by the tests, what percentage of statements, how many branches of the statements, if it's like a, if else, and how many potential iterations can come out of that, what percentage of the functions and which lines have not been touched by the tests. So it produces this really cool report that you can then use to say, okay, we need to focus more on, this contract or this function. So let's go through a quick demo with testing now. So once again, we're going to work with the starter kit because it's kind of got some tests in there for us to play with already. And if we go to the test folder, there's 2 folders here, integration and unit. So the unit tests just basically do, like we explained earlier, these simple tests that kind of just test a single condition and where no kind of interaction is required. So in the API consumer test, for example, it just tests that a request ID is generated when you call that request volume data function. Whereas if you look at the integration test for the API consumer smart contract, not only does it test that a request is generated, but it also sends the request and then it waits 30 seconds for the Oracle to receive the request and then actually checks the volume getter function to see that we actually got a result from the Oracle as well. So it tests the integration with the Oracle to see that we actually got a response back. So that's kind of an example of a unit test versus an integration test. So there's a couple of tests for each of the smart contracts here, and you can kind of go and see them and see the syntax that's used and how they use Chai and things like that. But for the purposes of this demo, I'm just going to run them. So we're going to run our unit tests on the Hardhat network, which I should still have running here. And I'm going to make sure this is set back to normal. In fact, I'm going to restart my Hardhat node. So now I'm going to run a yarn test here. And what this actually does is, if you look at the package.json, there's the scripts section here and it says test. So when I run yarn test, it literally just goes here and it runs all of these commands one after the other. So you can see there's, we're essentially just running each unit test script in a specific order, and it's basically just doing it for us. So as you can see, as we run each test, we kind of get an output, and then we either get a tick or a cross, depending on whether the test passes or fails. And this is all happening on our local Hardhat network. I think mine is actually still running a forked version of the mainnet, but that doesn't matter. So there we go. Each of the unit tests passed successfully, and we can kind of see the output there. So it went through each of the tests in my unit folder here and it executed them. So let's say I wanted to now execute the integration tests. To test the integration test, because they make use of Chainlink oracles, we need to do it on Kovan. So I'm going to change the network to Kovan, and I'm now going to run, I'm going to redeploy the contracts to Kovan. So we'll just wait for that to complete. Okay, there we go. And now I'm just going to run yarn test integration, which is going to then run, no, that's the wrong one. It's going to run all of these commands. So npx hardhat test, API consumer test, npx hardhat test, the random number consumer one. I think there's only two there. So the integration test will take slightly longer because we have that 30-second wait, and it's on Kovan, so we have to wait for blocks to be mined, etc. But hopefully, if we wait a little bit, we should see that the integration tests are successful as well. And then once that's done, I'll show you guys the Solidity coverage as well. The final step, I think, in this exercise, which hopefully we get the time for, we've got another bit under an hour, is to actually check in your project to GitHub, to check it into a public repository, and to kind of get some experience in kind of using Git as well, which is a repository manager. So I'll try and show that to you guys as well. So the API consumer integration test has successfully passed. As you can see, we get the volume listed there, and the random number consumer test is currently executing. So while I'm waiting, I can open that up and see what it's doing. It's doing a random number request and verifying that it gets a result that is greater than 0. So it verifies that we actually get a random number back and that it's a number that's greater than 0. So there we go. Both integration tests are now successful. So what I'm going to do now is I'm going to change the config back to the Hardhat network, and I'm going to run the Solidity coverage report on our unit tests. So we're going to put npx Hardhat coverage once you install the coverage plugin, and it will compile our contracts. It will look at the unit tests, and then it will generate a coverage report for us. So I'm just going to make that a bit smaller. Cool. And there's our Solidity coverage report. So you can see here are all our, let me see if I can make that a bit bigger. Nope, too big. You can see our smart contracts here, right? And it says what percentage of the statements were executed in our unit tests, what percentage of branches, what percentage of the functions, and what percentage of lines overall, and which lines have been identified as, you know, things that haven't been looked at in the tests. So as you can see, the price consumer one looks really good, but the random number consumer tests could use some work, as you can see. So that's an example of a solidity coverage report. So the final step is, let's say you want to check this into GitHub now. You could check this project in, or your My First Contract one if you want. So I'm just going to quickly show you guys how to do that with Git. So I'm going to go new repository. I'll just call it something. Go create repository. We'll leave that there. And then we're going to go back to our terminal here. Oops. And we're going to do some Git commands too. So hopefully you guys installed Git while doing your setup. So we're going to initialize the local directory here as a Git repository. We're going to add everything here to that. We're going to remove any remote connections that may be there. Then we're going to commit everything that we've got here to a new commit, developer bootcamp. Then we're going to go back to our repository that we created and copy this URL that you get. We're going to add it as an origin so that Git knows where to push stuff to when you send it. And the final command should push everything to that repository. If you're worried about your .env file, it shouldn't be uploaded because we, in our .gitignore here, which is a file that tells Git what files to not include, we've specifically specified the .env in here. So hopefully if I show you guys mine now that I've done, there we go, that's finished. All you do is you refresh the page and you can see here's your project. And you can see the .env file, which I have here, has not been included in the repository here because we created it. We created it ourselves, but in the .gitignore here, we're actually saying don't include this in the repository. Don't push it anywhere. So that's the final step of the exercise, and this is the last exercise actually. So you can do. If you complete the testing, you can then upload the starter kit if you want, or you can switch your VS Code and go back to your My First smart contract, and you can actually run the same commands as well on that one, and it should get you to the same place. You create a repository on GitHub here, and then you run the commands on your My First smart contract and you can check it in. So either of the two, feel free to choose which one. I've just done it on the starter kit here because it's the one that I had open. But I'll pass it over to you guys now. We have about 45 minutes. So I'll give you about 35 minutes, should be enough, 35 to 40. And then we'll just spend a few minutes wrapping everything up. So let us know how you go and let us know if you have any questions or issues. Okay, guys, let's wrap this up now. So I think most of you were hopefully able to get through the testing exercise, and I saw a whole bunch of yous posting GitHub URLs, so awesome to see. Let's come to a conclusion now. So we finished day 2, congratulations. What have we looked at today? Today, we looked at the Hardhat development environment. We looked at the Hardhat starter kit, which is a prepackaged repository that kind of contains all of the kind of things that you do in Hardhat, and we use them to deploy and interact with smart contracts that use Chainlink. We did some local development in Hardhat. We forked mainnet as well. We talked a bit about smart contract security. We ran some unit integration tests, and we published our code to GitHub, hopefully. So just wanted to say a couple words to finish off here. Where can you go to learn more now as a developer? There's a whole bunch of Solidity resources out there. Obviously, there's only so much we can teach in a 8-hour course over the course of these 2 days. So if you want to learn more about Solidity and the ins and outs and some of the things we haven't looked at, there's some great resources here. Crypto Zombies is really popular. There's some other courses you can look at as well that are listed there. They're all really great. If you want to learn more about Chainlink specifically, head to our docs at docs.chain.link. There's a wealth of information there, hackathon resources, tutorials, all of that kind of stuff. We've got a special developer section in our blog too at blog.chain.link, where there's some really cool step-by-step blog posts and articles for developers that kind of walk you through doing some really cool smart contract type things, such as building a dynamic NFT using Hardhat, creating a parametric insurance smart contract, or getting a random number on Polygon, things like that. For those who are asking, we'll send these out in an email, all the slides and stuff, and they'll have all the URLs in case you miss some of these. Chainlink YouTube as well. We've got a really good engineering tutorials playlist on our official YouTube with a whole bunch of stuff on there, and we're constantly adding to it as well. So definitely check that out. And just wanted to say, if you do go on to build projects that use Chainlink nodes, just a couple comments here. Some testnet jobs or nodes on market.link aren't active or running. So it's always best to contact the team before you choose a job on market.link and say, hey, I want to use your job. Just want to make sure it's running and that it's not whitelisted or anything. B, the market.link verification is currently being reworked. So nodes or jobs of new or active operators won't always show up in the search results if you're searching for a specific one. 3, there's a bunch of active node operators on Discord, such as the Link Pool guys, Link River, etc. And they're all keen to run jobs for you and to kind of gain practical experience and work together with devs to help them realize their projects. So if you need a custom job run on a Chainlink node, if you need an external adapter run, feel free to reach out in the Chainlink Discord in the operator request channel. And 4, just besides using things like price feeds, any API, VRF, pretty much anything can be realized using customized decentralized Oracle networks, where developers and node operators can kind of work together in a complementary manner. So feel free to kind of come up with any ideas and then reach out to node operators to kind of help you realize them. And yeah, that's about it. Our Discord is a great place for interacting for those who haven't been there yet. If you want to chat to other developers building smart contracts, if you want to chat to other developers building things with Chainlink, definitely head to our Discord and kind of interact with us there. We're happy to help you out if you have any questions or issues. And that's it. Just wanted to say thank you, guys. You have now completed the Smart Contract Developer Bootcamp Day 2. We went through so much today. This was a huge day, probably the biggest out of all of them, considering the weekday ones ran for less because they were spread out more. But you guys got through it. You hopefully have a good idea of what it's like to create, deploy, and interact with smart contracts, as well as how to use Hardhat, how to do local deployments, and about testing and all of those things. So all these things smart contract developers do on a day-to-day basis, and you guys have now done that. So you've taken your next step in your journey as a smart contract developer, or just as someone who wants to kind of play around with smart contracts. So can't wait to see what everyone builds now. We hope you continue to learn, continue to build things, participate in hackathons, create projects, and all of those cool things. And yeah, we really appreciate you spending your weekend with us learning. We really had a ball giving the course to you guys. It was great fun. And we're going to hopefully run more of them in the future, both online and in person. So yeah, with that being said, thank you for everyone for joining. We wish you all the best as you continue your smart contract developer journey. Thanks, guys.
Thanks, everyone. I was so impressed with the skill level everyone reached at the end. So.
Oh yeah, definitely. And thanks to all the helpers, both in YouTube and Zoom as well, for all your help. We appreciate it.